Hi, this is the first video in a series of videos all about Pixi.js. Now, Pixi.js is a good choice for 2D graphics in the browser. It's somewhere between Phaser, which may be a little bit too opinionated for you, and WebGL, which tends to be a little bit too complicated. A lot of projects are based on top of Pixi.js, including Phaser. So without any more faffing around, let's get up and running. So I will have a link in the description of the video which will take you to this address. And this is a starter project which will get you up and running with Pixi.js in next to no time. You will need to fork this project if you want to change it. So if we click on this fork button, and then it will ask you to sign in to CodeSandbox.io. And you can either sign in with GitHub or Google. So I'm going to sign in with Google. So the nice thing about doing it this way is we're up and running already with Pixi.js instead of going away for 20 minutes installing various bits of software. But I'll break down this Pixi.js template so that if you do have Visual Studio Code installed, you can get up and running with a similar template. So if you wanted to get up and running locally in Visual Studio Code, you could paste in this package.json file into your project folder and then do an npm -i or npm install, and that will install snowpack and Pixi.js, and you can either delete these or keep these in. I find that Victor's very handy for doing vector calculations, and matter.js is a very good 2D physics engine. I also highly recommend installing CodeSandbox.io as an application, and you can get up and running quickly with Pixi.js by clicking on Create Sandbox, Import Project. Then you can link directly to my snowpack Pixi.js template on GitHub, and I'll put the link in the description, and then click import and fork. And as you can see, we have live reload working. So if we don't add the square, then the square immediately disappears. And that's one of the good advantages of using snowpack. So we have a very basic index.html file, and we just have this h1 tag here, which is this, and then we have our canvas, which is this area here, and then we link to our index.js file, which is a type module, and that's here. So the first thing we need to do is we need to import Pixi from Pixi.js. These are commented out for the moment because we're not using it in this simple bit of code here. So I'm setting my canvas size to 256. And then I'm getting a reference to my canvas, which is this canvas here. And then I'm setting up the Pixi application to use this canvas here. I'm setting a background color of this green. And if I remove all this code here, that is enough to create a green canvas like this. And we can change the canvas size as simply as changing this value here. Now we're adding in a square. So I'm setting a square width of 32 pixels. So I'm creating a sprite here on this line, a Pixi sprite. And I'm setting the anchor of the square to its center, 0.5. Then I'm setting the square's position to be right in the middle of our Pixi application. Then I'm setting both the square's width and the square's height to the square's width. Then I'm coloring our square, and even after doing all that, you don't see our square until we add it to the apps stage using add child. And now we have our square in the middle of our canvas. Now let's get this square looking towards our cursor. So if we move our cursor around our square, it will look in that direction. So Pixi.js has this very handy ticker, which is essentially our game loop. So we can set up our game loop as simply as that. So now any code that goes inside here will get run over and over again. So we can get our mouse cursor position by doing app.renderer.plugins.interaction.mouse.global. And so we want to rotate this square by an angle. Looking straight up would be an angle of 0. Looking off to the right would be an angle of 90 degrees. Or in radians, that's pi over 2. Looking straight down would be an angle of 180 degrees, which in radians is pi. And so you get the idea. So the way we can find that angle is with a very nifty function called tan2, which looks scary, but actually it's not. It essentially takes a y and an x. If you think of the x and the y axis, if we have a point and the origin being in the middle at say 0, the mouse cursor over here at xy, a tan yx would give you this angle here. This is what I mean. So a tan 2 will give you this angle here. So that's not exactly what we want. We actually want this angle here. So we'll need to adjust it by pi over 2. But apart from that, a tan 2 is pretty perfect for our means. And this bit here is that adjustment I was telling you about. We need to adjust it by pi over 2. And we're getting essentially the offset vector between the cursor and the square by taking away the y and the x. So this essentially gives you the offset between here and this point over here. So we want to set our square rotation now equal to angle. And there you go. We have our square rotating to face our cursor. So that's our first video on our series that introduces the fundamentals of Pixi.js. In video 2, we will have a whole horde of zombies coming in from the edges of our canvas, coming to attack our player. Fun times.